All right, folks. So we'll go ahead and get started. Of course, this is a repeat of the session that happened on Tuesday, but again, we're going to go a little bit deeper because I know Gil went ahead and requested that he wanted to know about each level of the are we doing a new link for today? Nelson, can you answer that? Just let them know to go to just go to go to the calendar invite, click on the link that's for this day. That's how Zoom works. If you can, buddy, thank you. But back to the studies, right? So Tuesday, again, we went over the TCP IP model. And so I have some, okay, perfect. So we went over that. We went over how that's implemented, and of course, Gil requested to go over the OSI model and how that compares. So we're going to touch on that. Tuesday, you guys missed it. Greg did ask some great questions. So again, guys, I'm gonna let you guys know. Stop me. Do what you have to do. Ask any questions that you would like, right? And I'll answer it to the best of my abilities. And hopefully, it adds value to you and your studies or what have you. Okay. All right, so let's go ahead and get started. So again, going based off of chapter 1, right? So chapter 1, it goes diving deep into basic computing, right? Talking about the TCP IP networking model, right? And so what it's going to do, right? And you guys are probably thinking in your mind, or probably not. You probably are like, oh, TCP IP model, is that different from the OSI model? It is, right? So the TCP IP networking model, this is what your computer actively uses, right, to communicate on a network. Simple as that, right? The OSI network model, reference model, right? That is a conceptual model that goes over protocols, adjacent layer communication, and same layer communication, right? At a super low level, right? In detail, right? So it's broken. So this is 5 layers. The OSI model is 7 layers, but we're going to touch on the OSI layers a little bit later. So let's go ahead and jump into TCP networking model, right? So we got 5 layers, right? And of course, the chart shows data link and physical layer being 1 layer. That's typically how it was before this most recent change. So they broke up the data link and the physical to the to 2 different layers. Greg, if you can put the link to Zoom in Teams, please. I think Nick is still trying to join the old meeting.
I got you.
Thank you, brother. All right, so with that being said, right, let's go ahead and go over this, right? We have the application layer, we have the transport layer, we have the internet layer, and we have the data link and physical, right? So the application layer, that doesn't necessarily mean, right, applications run at this layer, right? Oh, Outlook, okay, application layer. That's not what it means, right? We have an application on a computer, right? So maybe we have Outlook on Cornelius's computer, right? So that application, it communicates with the TCP IP networking model to say, hey, this application I'm using, I need to utilize SMTP at this moment, right, to send mail. So it's saying, all right, perfect, we'll go ahead and do that, right? And so what's going to happen, and I know I mentioned this term earlier, it's your computer is going to go ahead and say, hey, I have the TCP IP networking model installed on my computer. I'm going to go ahead and start encapsulating this packet, right? So that it can become a frame, and of course it can turn into bits and get onto the wire. Does that make sense?
Sure.
Okay, good, right? And so what's going to happen, right, is before it can go ahead and get on the wire, right, the TCP IP networking model that is on your computer, it's going to say, perfect, let me encapsulate it to where this application, Outlook, on Cornelius' computer can go ahead and interface with the TCP IP networking model, right? Hey, Cornelius's request was for SMTP. Now we need to go ahead and say, before we can send it out and it can leave this computer, we need to go ahead and use a way of transporting, right, this packet, right? We need to see, do we need to send this reliably or unreliably? We'll talk about that later, either TCP or UDP, right? So don't take notes on that now, just remember that in your head, right? Next thing, right? I told you guys on Tuesday, and you guys hear it from me all the time. with networking. Always, right? Layers 3 to layer 2, source and destination. That's it, right? So from a layer 3 perspective, IP addressing, right? So the computer needs to know where to send it, right? Source IP, right? And destination IP, okay? Where it's coming from, where to send it, all right? Simple enough. There's other protocols that operate at that. You guys see ICMP, Internet Control Management Protocol, right? Pings, right? But we'll touch on that a little bit later when we do our labs, when we have Fun Day, which is every Friday, right? Then the data link and physical layer. Again, on the left, the table shows them combined, right? That is the old TCP IP model before that was redefined probably around 7 to 11 years earlier from today. Well, from this year. So now they broke it back up. They broke up data link and physical. And basically, data link, it's your layer that handles a lot of protocols that deal with MAC addresses, communications between a broadcast domain, right? Collision domain, right? Any protocols that operate there, and we'll go over that, right? So on our Fun Days, we're going to do our labs within my EVE-NG virtual instance, and I'll show you guys packet capture so you guys can actually see that, okay? Also, right? Some of you guys already work in tech, 802.11, Wi-Fi. All those MAC addresses and protocols, they operate as there as well, right? Now let's go ahead and switch over to layer 1, the physical, right? For this TCP IP model that operates any media you see, anything physical, or computers, or have you, adapters, all that is layer 1, right? Any media that's used to transfer bits, right? Via electrical signals, right? Or the air, right? Using wireless, or light, right? Fiber connections or what have you. So hope that makes sense, okay? So just remember this. And again, we're gonna go ahead and compare it to the OSI reference model. So Gil, I haven't forgot about you, okay? Cool. All right, so let's go over them. Let's go over them one by one, right? Each layer in the TCP IP networking model. Again, this is what is actually implemented, right? Microsoft, Linux, they actually use on host to go ahead and send and receive traffic from internet adapters, okay? So real quick, right? We have Bob and we have Larry. Bob is, he's at the PC. Larry, he's a network admin that's administrating the web server, right? So we have that, right? We have Larry here, and we have, use another color, and we have Bob here, right? So at a super high 3,000 foot Superman level, right? Bob's PC and his web browser says, hey, give me your web page, right? I'm trying to get to Google, right? And Larry's server, right, which is at Google, it says here is the file home.htm, right? I don't want you to worry about what .htm is. Just I want you to understand the logical basics of how that works, right? Okay. So of course, down below, you see, of course, in detail at a low level, what the browser is actually doing is sending a GET, right? So I'm not going to go deep into that, right? You guys can see that, and you guys can, of course, read your book and actually see the same infograph, right? But again, it all comes down to source and destination, right? Right? How a PC, how a host tries to reach out to a resource, right? This is how, again, a PC interacts with its TCP IP networking stack that's installed to go ahead and communicate with a resource, with a destination, et cetera, et cetera. Does that make sense? Okay.
Yes, it does.
Okay, all good. So let's go ahead and keep going. All right, perfect. So I know Greg had a question about this. He had a question about this other day, so I'll go ahead and touch on it, right? One thing you will have to know, of course, you see the book, and these are screenshots from the book, by the way. These are not made by me, okay? So the key topic, same layer interaction on different computers, adjacent layer interaction on the same computer, right? I'm gonna just go ahead and read the actual definition that Cisco lays here, right? Same layer interaction on different computers. The two computers use a protocol to communicate with the same layer on another computer. The protocol defines a header that communicates what each computer wants to do, okay? So let's go ahead and use an example, right? Nelson, for some odd reason, has AOL Messenger on his computer, right? So he lives on some island with himself, right? And this is the only way he can communicate with Cornelius. So Cornelius installed AOL Messenger, right? So he sends that message, right? And that the application interacts with a certain layer, right? Let's say layer 5 for the TCP IP networking model, right? The application layer, right? Because we're going to go ahead and interface with the actual protocol, right? That message, that application is only going to see the application layer on Cornelius's side. It's not going to see anything else. It's going to see just that. That application is just going to interact with just the application layer. That same layer interaction on different computers. Now, adjacent layer interaction on the same computer, right? Greg, help me out here, right? So we were talking about encapsulation and de-encapsulation, right? Before every host, every PC puts something on the wire, it has to go ahead and go through a process to go ahead and say, all right, it's ready to go ahead and be sent out, right? Similar to writing a letter to your grandmother, right? You need to go ahead and after you write the letter, you need to write the address, right? From who it's coming from, Greg, and to the grandma, right? So Greg, I don't know your grandmother's name, Grandma Wandizimo. That's what we're gonna call her. So we're going to go ahead and write the address. So we have our source and destination, right? You can think of it has that, right? On both the IP and the MAC address data link layer, right? And then, right, if we, of course, using that analogy of the postal service, and we'll touch on that a little bit later, what's going to happen is all these layers within the TCP IP networking model, now they all work together to go ahead and create a frame that's now ready to be sent out. So Greg has that analogy, right? Using the postal service. He's now done everything he has to do to go ahead and send this letter out to his grandmother, right? So Grandma Wandizimo can now go ahead and get the letter. Greg can go ahead and drop it off in the mailbox. How it gets there? Postal service. Now going back to our computer networking example, right? So what's going to do is now that it's ready, right? It's ready at layer 2 at a frame level. Now can go ahead and get transferred into ones and zeros, bits, right? And these are turned into electrical signals, okay, that are pushed on the wire, and it's going to encapsulate this entire frame to be shot out, right? Adjacent layer interaction enables this. Then, right? Then, if we're going back to the AOL Messenger example on between Nelson and Korn, when Korn's computer gets this, right, it's going to go ahead and de-encapsulate, right? So it's going to open up that message. Computer's going to say, all right, cool, this is destined for us. This. I'm going to go ahead and go through all the layers, do all my checks. Then, perfect. Application layer is going to say, hey, we got something for you, AOL Messenger. Nelson says, good morning at 4 o'clock in the afternoon. Something Nelson would do, right? But again, just an example. Hopefully that makes sense, okay? So that's the difference between same layer interaction on different computers, adjacent layer interaction on the same computer, okay? So, of course, you guys are looking at this slide. It's talking about TCP IP transport layer, right? So what the transport layer does, right? It basically says, do you want insurance on this whenever you send this package out, or do you not, right? I know some of you guys on this call sends a lot of FedEx packages. Do you want insurance on this package or do you not, right? That's all it is, right? At a very high level, right? And so we have two protocols. We have TCP and we have UDP. I want you guys to remember these two things. And again, it's going to be simple because again, this is chapter 1. We're going to dive deep into it later, right? And we're going to do some packet captures and all that and have fun in the labs later on. TCP, packets are sent reliably, right? So what I mean by that, if we're using Nelson and Cornelius's example, from Nelson's computer, right? If he's sending that good morning message at 4 o'clock in the afternoon to Cornelius's computer, if his computer is programmed or the application is programmed to use TCP and it says, I want to use TCP, it's going to get that, send it to the TCP IP networking stack, and it's going to say, hey, send it reliably, right? So I need to know that it got to Corn, right? And I know it got, and I need to know it got there reliably. If it didn't, I need you to try it again, okay? On the flip side of that, we have a protocol called UDP, okay? And so it's going to send things unreliably, right? So basically what your computer is doing is, if we're talking about football, it's going to send a Hail Mary, right? If you got it, you got it. If you don't, oh well, we're not going to try to resend it, okay? So going back to the Nelson Corn example, Nelson sent that good morning message in the afternoon at 4 o'clock in the afternoon. Corn never got it. And then of course, Nelson gets mad at Corn and says, you didn't get my good morning message, whatever, right? So basically that's what it is, okay? So, and if you see this infograph, you see that example right here, right? Let me go ahead and use an example, right? I'm gonna go ahead and circle this with red first. And then let me go ahead and go here, right? So again, Nelson's computer sending that first message and it got lost, right? And so what Nelson's computer, if his application is using TCP, it's going to say, oh, hey, we're using TCP. We're going to go ahead and send it again, or send whatever was missing, okay? And then Corn's computer is going to say, hey, I'm going to send you an acknowledgement saying that I got it. Again, don't want to get too deep into TCP and UDP because that isn't a lesson in itself, but hopefully that makes sense of how the transport layer works in the TCP IP networking model. Let's go ahead and move on. Again, feel free to ask questions if something it doesn't make sense. Okay. Let me go ahead and grab some water. Give me 1 second. Any questions, guys, while I'm grabbing some water?
For me so far.
Cool. Cool. Is it all making sense?
Yeah, it is. I was gonna ask a question, but it's probably like not important. It was more like diving deeper into TCP, UDP, just as far as like when you would use each one in that transport layer.
No, that's a good question. So again, we're gonna go ahead and jump on that in the future, right? So I don't, and of course I want to do my own dive deep research to actually show you guys how that works and how that's set, right? So, but at a high level, that's typically sent down from the application to say, hey, use this.
Okay, so the application determines that,
right? The application, but we'll see that. I'll show you guys that in the future whenever we have Friday Fun Lab Day. Okay.
Bet.
Okay. So guys, again, this jumping back right into it, the TCP IP network layer, right, works just like the postal service, right? Going back to Greg sending a letter to Grandma Wandizimo, right? Same thing we were talking about before, right? He wants to go ahead and send packets, right? It's going to go ahead, that network layer, so he has the address on the top left corner of the mail. It has his name, address, city, and zip code. What you can think of that as is the IP address, right? For some of the parts of the mailing address, right? And of course, he put his Grandma Wandizimo's IP address information on it, her mailing address. Boom, right? And so what are these little things? What are these? Right? You can think of, boom, exactly, right? And so these are routers all throughout the internet, right? And so they all know how to talk to each other, no matter where Greg is. And it's just like the postal service, right? Greg can be anywhere. He puts in the mailing addresses on both sides from himself, the source, and to where it needs to get to, the destination. He can drop it in any mailbox, anywhere. He'll go ahead and drop it there. Postal service will take care of the rest. Similar to what a PC does, right? Whenever it's sending a packet to a destination, it's going to go ahead, a host is going to go ahead and send it to its gateway. Gateway is going to say, I know where to go from here, right? And that router is going to work with the postal service, hand it off, boom, it's going to go through the internet, and then finally get to Grandma Wandizimo house. Does that make sense?
Yes, sir.
Okay, so later, right? Because routing is fun to me, and of course I'm doing it a lot within my CCIE studies. I actually started playing with BGP. We're going to touch on that later. Luckily for your CCNA, You will only need to know OSPF, and I will be delicate going over that with you guys, because that's very paramount to go ahead and know about how routing works, how routing concepts works, not just the actual dynamic routing protocol, but how routing in itself works, right? A lot of people get confused. I've seen it, okay? But does this make sense at a high level, how routing works at the TCP network layer?
Yes.
Cool.
Does to me.
Cool. All right. Again, another example of how that works. I showed you guys, of course, and we talked about the Grandma 1D's email and Greg's example. So I'm not going to go over this. Take a screenshot if you need to. Okay, when we're done with chapter 1, I'll send you guys this PowerPoint so you'll have it for yourself. But yeah, basically he's going over what we've seen before, right? Larry, right? He's sending it to his default gateway, which is router 1, and the router 1 will take care of everything from there, send it where it needs to go to, and then boom, router 2 is going to get it. It's going to say, hey, I know where it needs to go to. I know where the destination is at. It's going to go ahead and send it to Bob. Okay. All right. And you can see right there. Let me go ahead and make a quick note. I don't want to speed past this. I think this is a good part. Right. Go ahead and look here. Look here. Right. So HTTP, TCP, right? That's the IP header, right? It's encapsulated inside of those other layers, right? So if we're talking about the TCP IP networking model, right? Layer 5 HTTP, right? That's the application layer. TCP layer 4, IP layer 3, right? So what's going to happen is when the router, right, layer 3 device, right, or it can be a multi-layer switch. I don't like to call it layer 3 or layer 2 switch. A multi-layer switch that's doing layer 3 functions, which is routing. It's stopping, right? It's going to go ahead and get that packet, right, and de-encapsulate layer 1, layer 2, and layer 3, which is the network, the network layer, and stop there. It does not need to look at the packet. Doesn't need to look at what's inside of it, what's at TCP or HTTP. It just needs to look at the IP address, the source, and the destination. Those are my 2 favorite words with networking. Okay, does that make sense? Every layer 3 device, every router, everything on the internet, it's just going to take a look at that. We have firewalls and stuff like that that will look inside the actual payload. But for actual routers, ISPs and all that stuff all throughout the world, it's going to look at the source and the destination. Make sense?
Yes, sir.
Cool.
Yep.
Cool. All right, let me go ahead, clear this up. All right, let's go to the next page. All right, perfect. All right, so we talked about encapsulating. Hopefully you guys get it, right? So with that, right, you know, if we're going back to the Nelson and the Cornelius example, right? So of course, AOL Messenger, Nelson sent that message, AOL interfaced with the application layer of the TCP IP networking model, right? So it has layer 5, layer 4, layer 3 has that information. But we can't just send it on the wire like that. We need to go ahead and make sure that the PC knows how to send it, right, via the wire. And that wire language is MAC addresses, right? Data link, right? It's called data link for a reason. Send that data on a link, real simple. So at layer 2, right, it talks via MAC addresses, right? There's other protocols that exist there, and we'll go over that. We'll have fun with that. Matt can tell you. I will have a field day with you guys on Spanning Tree. But at a high level, layer 2, MAC addresses, okay? And switches mitigate that traffic. Okay, so switches mitigate that traffic at layer 2, right? Because their language is MAC addresses, right? So that's when you'll hear about MAC address table, right? You may hear something about that whenever you guys go ahead and troubleshoot in your studies or what have you. But yes, MAC addresses, right? So in that Ethernet header, let me go ahead and get my handy dandy pencil out. Ethernet header, it's going to have that source and a destination MAC address, right? Ethernet trailer, it's going to go ahead and have a few things, right? It's going to have FCS, right? It's a frame check sequence that's checking to make sure that nothing is going on with this frame, right? Everything looks good, the checksum looks good, etc. We'll go over that in the future. Do not remember this. I just want to touch on some things that are be key for you to understand, okay? So it's going to, again, encapsulate, and you see my favorite word. It's going to encapsulate. So Nelson sending that message to Cornelius, his PC is encapsulating that message, right? Into that IP packet, into now a frame, an Ethernet frame, okay? Once it does it, like I told you before, now that it's at layer 2, it can go ahead and send it on the wire, right? Because now the PC knows how to send it. It'll go ahead and transfer it into ones and zeros, and then it's going to go ahead and transmit that, and it's going to go ahead and get to Cornelius. Cornelius is going to get it. Boom. What is he going to do? It's going to go ahead and his PC is going to know, hey, this is for me. It's going to go ahead and de-encapsulate. What does that mean? It's going to go ahead and take off this. It's going to check this and say, oh, this is for me. Let me take this off. Let me take this off, right? De-encapsulate. That's it. Then it's going to take a look at it, right? Of course, this is Larry and R1's example, but again, using Nelson's and Cornelius example, this is what it will do. Make sense?
Yes, sir.
Cool, cool. All right, so let's keep going. Another infograph, you guys can take a look at it. I don't want to go in too deep. So another example, of course, data encapsulation. I know one question yesterday from Greg was, does the TCP IP networking model, or any model, for example, does it encapsulate at every layer, right? So the answer is yes, okay? As you guys can see, it's going to encapsulate layers 5 through 1, okay? So that's what you're going to see.
Is that, I'm sorry, just want to be clear, is that for the TCP IP model, or is that for like the OSI model as well?
That's for the reference model as well. Remember, the TCP IP network model is what runs on your computer. The OSI is just a reference.
Gotcha.
That's not what runs on your actual PC. Make sense?
Yeah, yeah.
Okay. All right.
Yeah, it is.
Question.
Yeah.
Yes.
You see, with the encapsulations and checking with the protocol analyzer, you can. What I've come to see is that the encapsulation happens until it gets to the physical layer. So the physical layer actually also does encapsulation though, but then it doesn't add any data to the frame that it receives. It just shifts it away. So maybe that's just something that maybe someone might get to, because you see that anytime you're adding or you're encapsulating, data is added, but then on the physical layer, it just shifts the frame you receive. It doesn't add any more data.
Yeah, that's what I knew. I mean,
Nope.
that's what I thought, but like,
so I'm gonna throw you a doozy. So it actually does.
Okay.
Okay. So those ASICs, right? That and we're gonna get deep. This is not on the CCNA, right? I just want you guys to know this for your knowledge. This is higher knowledge. What those mechanics inside of a switch, right? Inside of any device is doing, right? It's transferring, it's encapsulating that frame into bits. And what the media is doing is changing it. It's changing the way that traffic looks. It's changing it from, frames and stuff like that, and changing it into electrical signals. It's being encapsulated at layer 1 as well, because it's changing how it looks. Then it changed that into electrical currents. That's how the 1s and 0 works. Does that make sense?
Yeah, so I'm just trying to clarify. From Wireshark, you can see that, let's say, if you're coming from the application layer, let's say HTTP, sends a payload that is about, say, 400 bytes. The TCP would add its payload, which is around 20 bytes. And the others would also add their own payload. But then when I calculate and check all of it, I see from the layer 2 to the layer 5, we are talking about TCP, but then I don't see any extra byte added at the physical layer, though it encapsulates it into the bits. But then I'm just trying to confirm or say that the physical layer like doesn't actually add data after it encapsulates the frame that it receives.
So, okay, so and let me, this is good, right? So first things first, protocol analyzers like Wireshark, it's not going to show you layer 1. First, that let me knock that out. Second, right? So what I'm telling you is CCNP to CCIE level knowledge. Okay, what you're going over is CCNA to going on CCNP, right? And so good investigation, right? I don't want to confuse anybody on this call about what I've learned and what you've learned. Okay, so I'm going to default to what you're saying. Okay, so guys, Max is right. No encapsulation is happening, right? From a CCNA level. It's not nothing, no encapsulation is happening at the physical layer. When you dive deeper, you see that is happening. Okay, but we're going to stay at the CCNA layer. Thank you, Max, for checking me. Okay,
Sure.
appreciate you. All right, let's keep going. All right, as you guys can see, there are different names, different terminology, right? For how those packets look coming from a computer. I'm going to always call it a packet, but again, right? It's the actual name for it is a PDU, right? But at different layers of the network model, it has different names, right? So the TCP/IP networking model, right? When it's at layer 4, right? Dealing with TCP or UDP, it's called a segment, right? Once that gets encapsulated, right? It's called and goes to layer 3, it's going to be called a packet, right? Dealing with IP addresses, what have you. Then whenever it gets to layer 2, it's going to be called a frame. And that's just right before it gets onto the wire. That makes sense? Cool.
Yes.
Yeah. Cool. Okay. All right. Just remember that terminology, because when you take the exam, Cisco loves to go ahead and throw doozies out there. So just remember that. Now, Gil, where you at?
I'm here.
Okay, perfect. Your favorite part, OSI model versus the TCP/IP networking model. Okay, so this is comparing the two, so you guys can see how it's broken up. You see how the TCP/IP networking stack said, hey, we're just going to go ahead and condense at the OSI model where we have application, presentation, and session. We're just going to go ahead and condense that into just one layer. Okay, and so OSI model, layer 7, application, TCP/IP networking stack, which is layer 5, application layer. OSI model, presentation, TCP/IP networking stack, that's still layer 5. OSI model, session, TCP/IP networking stack on your PC is still application. What does that tell you? Nelson, what does this tell you?
Sorry, repeat that question.
So looking at layers 7 through 5 on the OSI model and layers 5 on the TCP/IP networking model, what does this tell you?
That the session, presentation, and application all take place during the application layer or layer 5 of the TCP/IP.
Boom, simple as that, right? And so the OSI reference model, if you want to get the nitty gritty, this is, again, it's a reference. You can go ahead and take a look and see which protocols operate at layer 7, layer 6, and layer 5. Make sense?
Yes, sir.
Yes, makes sense.
Cool. All right. And after layers, I'm sorry, somebody had a question? Okay. All right. Thought I heard something. So after that, it's typically the same, right? Layer 4 and 3 and 2 and 1, typically the same between both models. All right. So Gil, do you see that's the difference?
Yes,
Does that make sense?
Yes, it makes sense.
Okay, cool.
Quick question. With TCP IP being the thing that actually takes place on our devices,
Mhm.
OSI, you said it was a reference, but is there like any actual practical use for it, or?
Oh, absolutely. Absolutely. So whenever we have lab fun day,
Mhm.
right? So protocol analyzers like Wireshark, we're going to go ahead and take a look at that. You'll see that those analyzers will break down the packet, right, that it captured based on the OSI reference model.
Okay.
You see what I'm saying?
Yeah.
So it still relies on legacy stuff, and it's going to show you, hey, session, presentation, application, transport, network, data link, physical.
Okay. I get
Okay.
it.
And so what that's going to do is, here's a use case. Greg, you're trying to troubleshoot Outlook errors, right? Right? Different protocols run at different layers of the models, both of them, right? And so if you're taking a look at the packet capture, you'll see, oh, here's this, here's that, here's this, here's that. What do I need to look for to see if there's something happening, right? If there's an error happening, or if there's no error happening to troubleshoot, right? What layer do I need to focus on, right? And so for the CCNA, right, we're thinking as if we're network admins, networks engineers, right? We're going to focus on layers 3 through 1, or 1 through 3.
Okay.
That's the CCNA focuses on, right?
Mm-hmm.
Okay. So, but you need to know everything else, because in the future, and of course you guys see it now, right? We need to know all of the layers, right?
Mm-hmm.
Because again, network admins we don't just work on routers and switches, we work on firewalls as well.
Mm-hmm.
But for the CCNA, layers 1 through 3. Okay.
Okay.
Okay. All right. So OSI data encapsulation terminology, right? PDU. What does that stand for? Protocol data units. Okay. So at each layer, there's a protocol that's used, right? And so just to keep it general, they're going to call it protocol, and there's data units within it. Does that make sense? So this infograph showing, based off the OSI model, we have layer 7 PDUs, layer 6 PDUs, layer 5 PDUs, and so on. Okay. And just a quick note, let me go ahead and point this out. Layer 2 is the only layer that has a header and trailer. Okay. You will not see a trailer any other layer. Make sense? Okay, all good.
Yeah.
All right.
Yeah, that's the data link layer, right?
Data link layer, absolutely.
Okay. Makes sense, which what you were saying on Tuesday and earlier.
Okay. Any questions, guys?
Yeah, I got a question. Might be a silly one, but that trailer that's applied at layer 2, right?
Mm-hmm.
With that, using your postage analogy, would that be like the return address, or how does that? Can you just explain that a little bit?
Sure. So that's the insurance. That's an additional insurance that you're adding on to the letter. So if we're going back to Greg and Grandma 1D's emails, he already paid for the insurance, right? At layer 4, right? Transport, right? TCP or UDP. All that trailer is an additional insurance, right? To double check. And what the post office does is checking to see if Greg is a real person.
Okay,
Make sense?
gotcha. Yep.
Okay. And what I'll
I
do
got a
next.
quick question, David, for that.
Sure. What's going on?
So that would really only be used in a TCP connection, right? It's saying, or actually just, so the difference between TCP and UDP, once that trailer is associated with the information, it's just saying, hey, it got here, or hey, it didn't, depending on the protocol. Is that?
At layer 4. So his question was about layer 2 and the trailer.
Right.
Right. And so remember, at layer 2, I stated there is one of the protocols that exists in the trailer is a FCS, so the frame sequence check, right? And that's checking to make sure that the checksum looks good, and this frame, there's nothing peculiar that has happened. coming down the TCP/IP network layer. Does that make sense?
Yes.
Okay. And what I'm going to do, guys, is pull up a packet capture that I have saved. Give me 1 second so it can make sense. Nope, this is not a good one. Give me 1 second. Let's pull this up. Let's see if this, there we go. Okay. So let's go all the way back to this one. Okay. All right. So you guys remember this, right? See the layers of the TCP/IP model. Let's take a look at this packet capture, right? Remember, I told you guys, packet captures still work at, they utilize the OSI reference model because, again, this is an application. It's referencing something, okay? So if we look at that OSI model, I'm sure if you guys
I know, I'm working on it.
And it will not go into routing
Okay.
table because the more.
I'm gonna mute. Yep. Thank you, Pete. And so with this, right, we're taking a look at the OSI networking model, right? And let's look at the packet capture. Like Max said, we see layer 2, we see layer 1, layer 2, layer 3, layer 4, layer 5, TCP/IP networking stack. Make sense? And it's funny, this packet capture is actually showing layer 1, but on a typical packet capture, like Corn, if I send you to go grab a packet capture from a switch router, what have you, it typically doesn't have layer 1, but yes, this captured the bits that is being sent onto the wire. And again, CCIE knowledge. Max, this is where I'm telling you, at layer 1, it is being encapsulated because it's being changed into ones and zeros. Again, CCIE knowledge. Go ahead.
Okay, sure. Yeah, I was saying that it does encapsulate it, but then the data, like we could confirm with the actual data that it sends on the wire. You see that it says that it receives 70 bytes on the wire. So, like from Wireshark's perspective, or from what I've been able to research so far, I don't see the physical layer adding data to it after it encapsulates. That's what I was trying to put across. But then it does encapsulate, but then it is not adding data to the frame that it receives. That's the part where.
Right, and you're saying it's not adding a trailer and a header.
Okay.
Not adding a header, not adding more data to the payload.
Yeah, it's not
It's
adding
just
any more
transmitting
data.
at layer 1,
Just
I think is what he's trying to say.
So
Yeah, exactly.
after layer 5, there will be no addition to the payload.
Not as like I'm saying, you see, it's coming from the data from the application down to the data link, then to the physical layer. So once it gets all the data at the data link and drops on the physical layer, it just transmits the data, doesn't add any more bytes to the data that it receives.
Right. So it's not going to add a PDU, protocol data unit, right? It's not going to do that. On the background, right? On the electronics within a switch, router, what have you, it's going to encapsulate it in the background. Again, CCIE knowledge, CCNA, yes, from a protocol data perspective, it's not going to add a header or a trailer. Does that make sense? Because again, it's not adding data to the frame.
Right.
Does that make sense, Max?
Yeah, I'm trying to, well, maybe probably when we start diving deeper into that, you could share some of the CCIE knowledges so that we could actually, and because at this point, I'm limited to the CCNA and then other analysis that I did with Wireshark.
Mm-hmm.
Yeah, so But from the data link perspective, I know that it would add the header and then the trailer.
Mm-hmm.
But then on the physical side, that's where I'm saying, though it's transmitted a bit, from Wireshark, I don't see it adding data to the frame that it received.
Yep, because it's not. That encapsulation happens right within the electrical phase, right? When it's passing through the ASICs on a switch or a router, right? So you're not going to see that. And you said a great point. You're limited to it from the CCNA level. From the CCNA level, it does not encapsulate it, right? So I agree with you. I agree with you there. It doesn't encapsulate it. CCIE level is a different story. So that's why I told you guys not to worry about it, right? General knowledge, it does not add a header or trailer, right? So there's no encapsulation that's happening.
Right.
Okay. CCIE level, we're talking about how devices work or what have you. It actually is happening in the background. Make sense?
Sure.
Cool, cool. Any other questions, guys? That was a good question by Max, and Max brings up a good point. Please don't overload yourself for information. You get on the networks, you get online, you will get overloaded with questions, with references, or what have you. Please stick to just the CCNA for now. This is a CCNA initiative. Just focus on CCNA, what you see in the book, what you see in your labs, whatever the book is telling you. We're just going to be learning what you need to learn so you can pass the exam. Okay? Don't worry about Wireshark, right? I just need you to know about things that we're going through within the course. Okay? All right. With that being said, any questions?
All good here.
All right, fellas.
All good.
All right. Well, ladies and fellas, with that being said, I'll go ahead and close the session. This recording, it'll be uploaded in about 30 minutes. And guys, if you have questions, feel free to reach out, okay?
All right, thanks.
All right, thank
All
you,
right, guys.
David.
Later.
Later.
Later.